Hello, my name is Michael Golden, and I'm here for the rock, paper, scissors application. We are now ready to start our coding of it, which is the fun part in some aspects, but can also be very difficult. I'm going to teach you some concepts about coding, as well as show you some ways to document what's going on in your code to kind of space everything out. So the first thing we're going to do is we're going to go in our design view of our rock, paper, scissors, and we're just going to double click the shoot button. What that tells Visual Basic is that we want something to happen when the user clicks on the shoot button. So if we double click, it will open up our code. Let me zoom in a little bit for us here. And you'll see it automatically created the start of our code. You'll see it says private sub btn shoot click and sender as object, e as event args, handles btn shoot.click. We're not too worried about all this stuff here. All we want to know is that this part of the code is going to handle btn shoot.click, which means when btn shoot is clicked, our code will execute. So I'm going to put some space in here for us. And now the first thing I'm going to do is I'm going to put a note in here. And to put in a note, you put a single quote. And you'll notice it turns green. I'm just going to type in dimming needed variables. So as I put my comment in here, you'll see it's green. This means that particular line is not going to be executed in the code. So we can put anything we want in here. Oftentimes coders will also comment their names and other information. That way, if they distribute their code, people can contact them if they have any additional questions about it. So when we dim a variable, we're actually telling the computer what type of variable that is. I have 4 specific variables I'm going to work with. The first one is called the player choice, which we're going to type in dim player choice as string. What a string variable is text. You will be able to learn more about various types of variables in another video on our website, so please look for that. The next one we're going to do is dim CPU int choice as integer. This tells it an integer or a number, a whole number is going to be used. The reason why I called it CPU int choice is that tells me it's the computer's choice and it's an integer format. I'm going to then do dim CPU choice as string. This is going to be the text version of what the CPU's choice was in our code. Finally, we're going to have dim winner as string. You'll notice right now our variables are underlined in green. This means they have not been used yet in our code. This just helps us make sure that if we have any sort of dimension, that we can take it out if it's still green when we're done with our code, because that means we added something extra. So the next thing we're going to do is we're actually going to get our player's choice from the text box we created. I'm going to put a note in here, getting player's choice, and then the actual code will be the variable player choice equals txt player choice dot text. So now the text in the txt player choice box is now put in the variable player choice. Now rock, paper, scissors is considered relatively a random game. Someone chooses from 3 different options. So we now need the computer to randomly generate an option. And the first way to do that is to generate some sort of random number. So again, I'm going to note what this part of the code is about. It's a random number. And I'm going to put in what each number represents. 0 will be rock, 1 will be paper, and 2 will be scissors. The reason why I'm typing this out like that is this is also what some coders would call pseudocode or fake code. It's code that in our mind makes sense, like a sentence that explains what's going on. But it doesn't actually do anything until we write a code for it. So first we have to initialize what's called the randomize. So I'm just going to type in randomize. And then below that we're going to put CPU int choice equals, then we're going to create an algebraic expression that tells the computer how to generate this random number. We're going to use 3 times R&D. So now we're going to make another comment, and we're going to tell it to assign string value using random number generated. Now this is a series of if-then statements that we create that tell the computer if it's equal to a certain number, then that's the computer's choice. So the first one we're going to do is if CPU int choice equals 0, then CPU choice will equal rock. Then we're going to say, okay, if that number's not equal, then what we're going to do. This is called an else if statement. Then if the number is not 0, we're going to do CPU int choice equals 1. Then CPU choice will equal paper. Finally, else if CPU int choice equals 2, then CPU choice equals scissors. And then we're going to end the if there. So there's our if statement for determining what the computer has chosen. Then I'm going to place string value generated into CPU's text box. So now we're going to tell the user what the computer chose, which is txt CPU choice.text will equal whatever the CPU choice was, so CPU choice. Now you're going to notice in the code here that it says CPU choice is used before it has been assigned a value. Because of the way we wrote our if-then statements, it thinks there's a possibility it will not have a value. However, that's not true because of the way we wrote our formula for the CPU init choice random number. The way we wrote it, it's going to have a number between 0 or 2. It's going to have 0, 1, or 2. So we're going to ignore that warning. For the sake of evaluating choices when we determine a winner, we want all text, both the user and the player, to be lowercase. The reason why we can do that now is we've already put the text in the text box of the CPU player. So now we can do lowercase because we don't care how the text looks. So I'm going to put a note that that's what I'm doing. And then we're going to do CPU choice equals CPU choice dot to lower. This is a function of string values. Any string value you have, you can type in dot to lower, and it will automatically make everything in that string variable lowercase. We're also going to do that with player choice. So now we can guarantee no matter what the player types in as far as caps in the name that it will easily be evaluated. So the next thing we're going to do is before we determine wins or loss, we're going to make sure we eliminate all ties that are involved. I'm going to make my note, determine all ties. And then we're going to start with if-then statements. If player choice equals rock and CPU choice So now we're going to start typing our if statement. If player choice equals rock and CPU choice equals rock, then our variable winner is going to equal the text tie. And we're going to end the if right there. So that's just the end if for that particular determination. Then we're going to do another if statement. If player choice equals paper and CPU choice equals paper, then winner equals tie. And then, of course, if they both choose scissors, winner is again a tie. So now we've determined all possible ties. Now double check your code. Make sure you have no uppercase letters in the if-then statements as far as the rocks, the papers, and the scissors. Because when you compare string values, a capital rock versus a lowercase rock is actually different. So now we're going to decide if the player has won. And again, I'm going to put some notes in here. So if player choice equals rock and CPU choice equals scissors, then the winner variable will equal U. This is telling the user that they have won. And why? Rock destroys scissors. Just like the old childhood game, rock always destroys scissors. This time we're going to do an else if. Player choice equals paper and CPU choice equals rock. Then the winner variable is again U, paper covers rock. And then another else if. Player choice equals scissors and CPU choice equals paper. Then winner equals U, scissors cuts paper. And now we're going to end our if statement, which our code already put that in for us. Now we need to determine all the lost states for the player. So if CPU choice equals rock, so if CPU choice equals rock and player choice equals scissors, then winner equals the computer. Rock destroys scissors. Again, we're going to go back to else if statements. CPU choice equals paper and player choice equals rock. Then winner equals the computer. Paper covers rock. And then finally, else if CPU choice equals scissors and player choice equals paper, then winner equals the computer. Scissors cuts paper. Now, there is a potential chance in our code right now, since we use the text box, that the user can type in something erroneous. For instance, they can type in bat or ball or anything else that's not rock, paper, or scissors. So we want a way in our code to just simply represent that. So if after all of this, winner has not been determined, and as far as coding wise, that means the winner variable is still null or completely empty, we're going to create an if-then statement that tells the computer to generate a different message. So if winner is nothing, then winner equals error. And if this simply puts an error in the text box, so no winner or no loser is determined, and displays it on there so no something accidental happened. This is also useful in the event that we type something wrong in our if-then statements that determine a win or a loss. That an error will also be generated. So if we see we played paper and the computer played rock, but it generates an error, we know it's something with our win statements. Then we're going to simply display the final message into the text box. This will be txt_winner.text will equal whatever is in the whatever is in the winner variable. And then that is the end of our code. So now we're going to try debugging our project. We're going to go up to start, and we're going to hit start. And we're going to go into your choice, and I'm going to type in rock. I'm going to hit shoot. Rock and scissors. Rock destroys scissors, so I won. Now paper. The computer beat me. So the last thing we need to look for is rock. Now, when the computer should have determined rock, it actually generated an error for me. If I put my mouse over CPU choice, it says CPU is nothing. So normally we would have to go through our code and figure out why CPU choice was equal to nothing. Normally that would be something in our if-then statements up here. So what we want to do is look at CPU init choice. And actually it generated a 3. Now I made an error up in the formula I created for my random number. I put 3 times random. And actually I want it to be 2 times random. So I'm going to put in a 2. I'm going to stop the debugging. And then I'm going to start it up again. And I'm going to type in rock again. And just go through the chute until all variables have occurred. So there's paper, there's rock, and there's scissors. So now all 3 instances occurred, and I know everything worked fine. So next thing I'm going to do is I'm going to go to paper. I'm going to hit shoot. There's paper versus paper, a tie. Paper and rock, I win. And paper and scissors, I lose. So now we know paper works fine. Now we're going to type in scissors. I'm going to hit shoot and go through all the potential options. There's paper, scissors, and there's rock. So everything's working fine there. Last thing we need to check is our error. So if I type in anything else, like if I type in a bat, it should just come up and the winner is, it'll say error, which it did. So everything's working great in my project. Now in the next couple videos you're going to see, we're going to make some changes to this to make it easier for the user And we're going to show you how to take already created design and already created code and change everything to better suit in the future.